Software quality assurance, or SQA, is an indispensable part of the software development lifecycle, ensuring we deliver high-quality, reliable software products to end users. Within this crucial domain, stress testing emerges as a critical practice. It involves intentionally pushing software systems to their limits and beyond, simulating extreme conditions to identify weaknesses and vulnerabilities. By understanding how software behaves under stress, we gain invaluable insights into its robustness, performance, and ability to handle real-world demands. Stress testing goes beyond the realm of normal operating conditions. It delves into the realm of extreme load, heavy user traffic, and resource depletion. By simulating these scenarios, we can uncover hidden flaws that might not surface during routine testing. These flaws could include memory leaks, buffer overflows, or concurrency issues that could lead to system crashes, data loss, or performance bottlenecks. Identifying and addressing these vulnerabilities early in the development process is crucial for preventing costly downtime, ensuring data integrity, and maintaining user satisfaction. Stress testing is not merely about breaking the software. It's about understanding its breaking points, its capacity, and its ability to recover. By pushing the system to its limits, we gain valuable insights into its performance characteristics, identifying bottlenecks and areas for optimization. This knowledge empowers developers to fine-tune the system, optimize resource allocation, and improve overall efficiency. In an era defined by relentless technological advancements and increasing user expectations, software systems must be resilient, reliable, and capable of handling extreme conditions. Stress testing plays a pivotal role in achieving these goals, providing developers and testers with the tools and insights they need to build robust and high-performing software that can withstand the test of time. Stress testing encompasses a range of techniques, each designed to simulate different types of stressful conditions that a software system might encounter in the real world. Understanding these different types is crucial for tailoring stress tests to specific applications and uncovering a wider array of potential weaknesses. Let's delve into some of the most common types of stress testing. Load testing. This type focuses on evaluating a system's performance under a specific load, typically measured in terms of concurrent users or transactions. It helps determine how the system responds to increasing demand, identifying performance bottlenecks and maximum operating capacity. Volume testing. Volume testing examines a system's ability to handle large volumes of data. It involves subjecting the system to massive data sets, testing its capacity to process, store, and retrieve information efficiently without compromising performance or integrity. Concurrency testing. This type simulates multiple users accessing the system simultaneously, often targeting specific functionalities or resources. It helps identify concurrency-related issues such as race conditions, deadlocks, and data corruption, ensuring the system can handle concurrent operations without conflicts. Resource testing. This type focuses on stressing the system's resources such as CPU, memory, disk space, and network bandwidth. By pushing these resources to their limits, testers can identify resource leaks, performance bottlenecks, and potential points of failure under extreme resource constraints. Environmental stress testing. This type simulates various environmental factors that could impact system performance, such as high temperatures, power fluctuations, or network outages. It helps assess the system's resilience and ability to operate reliably under adverse conditions. To truly grasp the significance of stress testing, let's examine some real-world applications and examples across different domains. E-commerce websites. Imagine a popular online retailer gearing up for a massive flash sale event. Stress testing becomes paramount to ensure their website can handle the surge in traffic, process transactions smoothly, and maintain data integrity. Load testing simulates thousands of concurrent users accessing the site, adding items to their carts, and making purchases. This helps identify bottlenecks in the checkout process, optimize server capacity, and prevent website crashes during peak traffic. Online gaming platforms. For online gaming companies, providing a seamless and responsive gaming experience is crucial. Stress testing plays a vital role in ensuring their servers can handle a large number of concurrent players interacting in real time. Concurrency testing simulates thousands of players simultaneously engaging in gameplay, testing the system's ability to manage player interactions, update game states, and prevent lag or disconnections. Financial institutions. Banks and financial institutions rely heavily on their online banking systems for critical transactions. Stress testing is essential for ensuring these systems can handle high transaction volumes, prevent unauthorized access, and maintain data security. Load testing simulates peak banking hours with a surge in transactions, while security testing attempts to exploit vulnerabilities under stress to identify potential security breaches. Cloud computing platforms. Cloud service providers manage massive data centers that host numerous applications and services. Stress testing is crucial for ensuring these platforms can handle fluctuating workloads, maintain service availability, and recover gracefully from failures. Resource testing simulates various resource constraints, while environmental testing mimics power outages or network disruptions to assess the platform's resilience. Stress testing is not merely about observing how a system behaves under pressure, it's about quantifying that behavior through meaningful metrics and measurements. These metrics provide objective data points that help us assess the system's performance, identify bottlenecks, and track improvements over time. Response time. This metric measures the time it takes for the system to respond to a request. Under stress, response times tend to increase. Monitoring response times helps identify performance bottlenecks and determine the system's capacity before performance degrades significantly. Throughput. Throughput measures the number of transactions or requests the system can handle within a specific time frame. It indicates the system's processing capacity and efficiency. Stress testing helps determine the maximum throughput the system can sustain before performance degrades or errors occur. Error rate. This metric tracks the number of errors encountered during the test, expressed as a percentage of total requests. As the system undergoes stress, the error rate may increase. Monitoring error rates helps identify specific error types, pinpoint failure points, and assess the system's stability under pressure. Resource utilization. This metric monitors the usage of system resources such as CPU, memory, disk I/O, and network bandwidth. Under stress, resource utilization typically increases. By tracking resource usage, testers can identify resource bottlenecks, optimize resource allocation, and prevent resource exhaustion.